Okay, this is our second basic R alpha method. Again, we've got R is positive, alpha is acute, so it's all going to be very straightforward. Okay, I'm going to abbreviate the working slightly here, but I'm still going to start from first principles and say that my 4 sine x plus cos x has to be this, and my first step again is going to be to expand that. Cos of a minus b, the minus in the middle, remember on the formula book the plus and minuses get swapped, so it's actually going to be a plus in the middle, and it's cos of a minus b is cos a cos b plus sine a sine b. So I'm going to get r times cos x cos alpha plus r times sine x sine alpha, okay, and that comes from applying the addition formula from your formula book. And then I'm going to do the matchy-uppy bit. So I've got a term here with a sine x in it. Go searching for the sine x on the other side, it's there. So the 4 I've got here must be supplied by this r sine alpha must equal 4. And if I go looking for cos x's, I've got a cos x here and I've got a cos x there. So this is 1 that has to equal the r cos alpha, that has to equal 1. Okay, now to find r, I could use the sine squared plus cos squared identity as we did in the previous example, but I'm now going to say I'm an experienced person and I know that I get r from equations like this by doing 4 squared plus 1 squared, effectively Pythagorasing them and doing the square root. I know I want the positive square root because r is greater than 0, so that's just root 17. And I know that to get alpha, I'm going to get tan alpha first, and I want the sine to be on the top and the cos to be on the bottom, so tan alpha is 4 over 1, and so alpha is given as acute, so I'm not going to have to muck around with a first alpha and a second alpha. I can just do arctan of 4 over 1, or arctan of 4, and my calculator tells me that is 1.3258 radians, and so all I've got to do to finish off is just write down the answer. So we needed to do something with this, and we've now got that it equals root 17 times cos of x minus 1.326 radians. I've gone to 4 significant figures here. That's a bit close to halfway. I don't know why I have. They'll very often tell you the degree of accuracy they expect. And we can't give it as exact. I can give r as exact, so I'll leave it as a square root, but alpha has got to be a decimal. So I've nearly finished, and once I've double underlined it, I really have finished. So that's that one. Hooray!